Section 4.6, Modeling with Square Root Functions. So here's our square root function, y equals a square roots of x plus b. So if we're given 2 points, we want to come up with that equation of that square root function that's going to go through those 2 points. So what we do is first we're going to plug in 1 point. So when we have 0, 9, that's saying x is 0 and y is 9. So y 9 equals, I don't know a, square root x is 0 plus b. Now the square root of 0 is 0, and 0 times a is 0, so we get 9 equals 0 plus b, which is really b. So right now we know that 9 is our b, and when we're solving this, what we're really looking for is our a and our b to be able to come up with this equation. So now I'm going to use the point 423, and again that's my x, that's my y, so 23 equals, I don't know a, square root of x plus b. Okay, but remember x was 4, so we're going to put that in, and b I also know now, so this is 23 equals, the square root of 4 is 2 to a plus b, remember we already found that, we know what that is, that's 9. So we're going to plug this in over here, and notice our result. Our result is one equation here with one unknown. We can solve for minus 9, and we get 14 equals 2a, divide by 2, a equals 7. So we have our a, we have our b. Remember, we're looking for the equation, so y equals 7 square roots of x plus 9. So that's going to be our model. That's going to be our equation that contains these 2 points. Now this was nice because we had the y-intercept, and if you have the y-intercept, you know what b is going to be. But we're not always going to have the y-intercept, and so when we use these 2 points, it may be a system of 2 linear equations that we're going to have to solve if we don't have that y-intercept. So now I'm going to find the equation that contains the points 4, 12 and 25, 33. So here's my 4, 12, x, y. So y is 12 equals a square roots of 4 plus b. I don't know what b is. This reduces to 12 equals 2a plus b. For my other point, 25, 33, again xy, 33 equals a square roots of 25 plus b, so 33 equals 5a plus b. Notice in this equation I have 2 unknowns. In this equation I have 2 unknowns. So what I have is I really have a system of equations now. 5a plus b equals 33, and 2a plus b equals 12. So I have 2 equations with 2 unknowns, which is a system, and if you recall in previous math courses, you could solve this system by graphing, you could solve by substitution, you can solve by the elimination method, which is the method we're going to use, because notice how there's always that plus b, so I'm going to multiply this equation by a -1, but I have to make sure I do it to everything. So my 5a plus b equals 33 isn't changing. I get a -2a minus b equals a -12. So I want to get those b's to be opposite so that when I add they're going to cancel out. So 5a plus a -2a is 3a. This positive b minus b is 0 equals 33 minus 12 is going to be 21, and notice I have an equation with 1 unknown. So I'm going to solve that, divide by 3, we get a equals 7. So there's my a, but I still need b. So I'm going to take that a and plug it into either one of these equations. So I'll go with the top one. 5a, I know a is 7, plus b equals 33. 35 equal or plus b equals 33 minus 35 from both sides, and we get b equals -2. So I have a, I have b. I had to get that from solving my system. Now remember, we're looking for the equation y equals my a, 7 square roots of x, and then plus my b, which is plus a -2, which is really -2. So there's my equation. Now you can check this by plugging those points in to this equation. So what's the square root of 4? Is 2. 2 times 7 is 14. 14 minus 2 is 12. Now I can also check it with my other point. It has to satisfy both these. The square root of 25 is 5. 5 times 7 is 35. 35 minus 2 is 33. So they do check. Something else that we could do on your calculator is if you go stat edit, we could put those points in. X is 4 and x is 25. My y when x is 4 is 12. My y when x is 25 is 33. So we go y equals, turn our plot on, and adjust our window, zoom 9. We're looking for that square root function that's going to go through those 2 points. If I go back to y equals and go 7 square root of x, and then get out of that -2, and when I graph, if this is my square root function, it should contain those 2 points. And you can see how it hits there and how it hits there. So there's multiple ways of checking this, and I do strongly recommend that you check it. Now, not all of our equations are going to be that nice, because if x is not a perfect square, it's not going to come out as nice. But if we do, we're going to find our equation, our square root function again. So for our point 2, 3, we're going to get 3 equals a square roots of 2 plus b. So notice the square root of 2 isn't that nice. We can't, it's not a perfect square. We're going to keep it like that. Or if you prefer, what we could do is we could go to decimals. The square root of 2 is approximately 1.414. So this is really saying 3 equals 1.4142 a, because that's what the square root is, plus b. Now again, we are rounding a little bit because the square root of 2 is not nice, but don't round to 1.4, because if you round too much, you're going to be off. Now if we use our, so there's our point. If we use our point 57, what we're going to get now is 7 equals a square roots of 5 plus b. And again, we could do it by approximating the square root of 5. So 7 equals, if we go the square root of 5, 2.2361. So 2.2361 a. So again, that's what the square root of 5 is, plus b. But again, notice I have a, here's a linear function, 2 unknowns. Here's a linear function, 2 unknowns. So as we go through now, we can solve this by 2.2361a plus b equals 7. 1.4142a plus b equals 3. Now we could have just stuck with the square root of 2. We could have stuck with the square root of 5 and worked with it over here, because remember, that's just the square root of 5. That's the square root of 2. Now to solve this by the elimination method, I'm going to multiply this by -1. My 2.2361a plus b equals 7. -1.4142a minus b equals -3, because that -1 has to go to each one. And when we combine these, notice that b is going to be 0. And 2.2361 minus 1.4142 equals 0.8219a, which equals 4. Now to solve for a, divide by 0.8219, and we get a equals 4 divided by 0.8219, and we get approximately 4.8667. So we'll say 67. Now, depending on how far you want to round, if it says round to the nearest tenth, nearest hundredth, nearest thousandth, so on. But here's our A, and now we're going to go through and solve for B. We could use either one of these. So I'm going to go 2.2361 times 4.867 plus B equals 7. So 2.2361 times 4.867, you get roughly 10.883 plus B equals 7. So subtract 7 minus that 10.883 now, because you want to subtract that from both sides. And we get B equals negative 3.883. So here's our B. So our Y now, Y is roughly 4.867 square root of x minus 3.883. So just to make that square root nicer, square root of x. So here would be our model containing those 2 points. And again, you could check it by using your calculator, plugging these 2 points in, plugging these 2 points. If you want to check it, we can go 4.867 square root of 2, get out of that, minus 3.883, should be pretty close to 3. And if I check it with 5, so I plug it back in, go to 5, I should be pretty close to 7. So this one's going to be nice again because I'm given the y-intercept, but not so nice because I don't have a perfect square there. So if I start with 0, 5, 5 equals a square root of 0 plus b, so I get 5 equals b. But when I use my 0.69, so that was my 0.05, when I use my 0.619, it's going to be 19 equals a square root of 6 plus b. But I know b, so it's 19 equals a square root of 6 plus 5. And notice this is one unknown, so we can solve for a by subtracting 5 to both sides. We get 14 equals a square root of 6. This is a times the square root of 6, so we can divide by the square root of 6 to both sides. And we get a equals, so 14 divided by the square root of 6, and we get 5.715. So 5.715. So we have B, we have A, so our equation is going to be y equals A 5.715 square root of x plus 5. And again, if you want to check it, you could plug those points in or check it on your calculator. If we're given some data here, so here we're given some data. Here is the year, the number of arrests. But when we're doing this, when we use our calculator for all those points, if we go stat calc, you're going to see down here, here's a linear regression, so if it's a line, a quadratic, if our data looks like a parabola, a cubic, or quartile, it's a 4th degree, a cubic was a 3rd degree. If we go down, we have a logarithmic, exponential, a logistic looks like an S-curve, and a sine looks like a wave curve. We don't have a square root function to plug in. If I go stat edit, if you can still see this, I'm going to go ahead and put my data in. So number of years is after, let's see, 2 years since 2000. So it's going to go 1, 2, 3, 4, 5. And my number of arrests is going to go 114, 207, 283, 326, and 364. And I'm going to clear out my Y, zoom 9 to see this data. And you can see there's that square root function, but I don't have a way for the calculator to generate a square root function. So what we have to do is determine the years. So given 2 points basically. So we're going to use 2002 and 2004. Remember here t equals 2 because it's 2 years after 2000, and t equals 4 years after 2000. So our first point is going to be 2, 207. So 207 equals a square roots of 2 plus b. And the square root of 2, so as we go through it, if you check it out, this is going to be, so this equation is really, and I like writing this first, so, or 207 equals that 1.4142a plus b. So if you prefer to work with a decimal for right now, we are rounding, so try not to round too much. Now if you want, we could just keep the square root of 2 there and continue with the square root of 2. For our point 4, we get 326. That's 326 now, equals a square roots of 4 plus b, and that reduces to 326 equals square root of 4 is 2a plus b. So notice we have an equation, 2 unknowns, equation, 2 unknowns. We don't know what b is. We weren't given the y-intercept. So now we're going to solve this system. 2a plus b equals 326, and 1.4142a plus b equals 207. So I'm going to multiply by -1 to get rid of my b's, but remember it's to everything. So I have my 2a plus b equals 326, negative 1.4142a minus b equals negative 207. And when we combine those now, So that 2 minus the square root of 2, which is what 1.4142 really is, we're going to get that 0.5858A. My b's are going to be 0 equals, and what's 326 minus 207, and we get 119. Now to solve for A, we're going to divide by 0.5858, and we get A equals, so 119 divided by 0.5858, and again that number there was 2 minus the square root of 2, and we get 203.14 roughly. So we have A. Now we have to go back and find B. We can use either one of these. I'm going to use the 2A. A is 203.14 plus B equals 326. So I'm taking this essentially and putting it in here for A. 2 times 203.14 is 406.28 plus B equals 326. Subtract 406.28 minus 406.28, and we get B equals negative 80.28. So our equation now, so if we want to find our model, our equation for all this is going to be y equals A, 203.14 square root of x minus 80.28. So here's our equation that we're going to use, and if we graph this, y equals 203.14 square root of x, and get out of this minus 80.28, and graph, remember I have all those points in there, and you can see that it's not perfect, but we did use this point here and this point here, so that's why it goes through those 2 points, but it's a pretty good fit. If it's asking for our y-intercept now, so here was the work. B is asking for the y-intercept, which is going to be 0, negative 80.28, and what that says is in 2000 the number of arrests was about negative 80. Now that's what, based on the equation, that's what this is really saying. But can you really have negative arrest? The answer is no. But based on that model, that's what it's saying. Now realistically, because this was our data, we probably should have started with 2001 as our 0, since that's when we started collecting this data. But if you're going based on the model, you know, it's saying that there was negative 80 arrests. Now if we want to predict the drug arrest in 2014, that's going to be T equals 14 years after 2000. So we're going to have 203.14 square root of x, and x is going to be 14 now, minus 80.28, and we're going to get, so get out of that, 203.14 square root of 14 minus 80.28, and we get 679.8. So it's saying it's approximately 680 arrests in 2014. Now predict which year, so now we're looking for T, when there are 730 drug arrests. So that's really what our Y is. Now we're trying to solve this 730 equals 203.14 square root of, I used X, square root of X. Probably should have used T, since that's what was given. So T, just going to change these to T. And again, why should I use T? Because up here it was looking for our, if you can see it, our function f of t. So it's saying T years. So our variable there should have been T. Minus 80.28. So I want to solve this for T. So I'm going to add 80.28. And we get 810.28 equals 203.14 square root of T. So now divide by 203.14, 203.14, and we're left with the square root of T equals 810.28 divided by 203.14, and we're going to get roughly 3.988 8. And now what do we want to do to solve that for T? We're going to square, because we're going to square both sides. So we're left with T equals 15.9. So it's approximately 16 years after 2000. So it's 2016 will be in which year. So I hope that helps for section 4.6.